Hello, everyone. Thank you for joining today's session. If you are able to see, see me clearly and hear me well, please let me know in the comments. We'll just get started in a minute or so. Okay, let's get started. If you are able to hear me well, please let me know in the chat. Very well. Okay, so let's get started. So for today's agenda, we are having this webinar to understand about the MLDS hackathon that's live on MachineHack website to get you know more about what MachineHack does, how you could benefit from it, and what are the ongoing events which you could be part of to help yourself. So I would get started with today's agenda. It's about mainly three elements. I would start to show you about the MLDS hackathon that we are having live on our platform. Then MLDS Ideathon, give you a walkthrough about how you could participate, how you could improvise your score and those aspects. And then we would conclude it with a quick Q&A session for 10 minutes. Prior to that, let me walk you through the MachineHack website. To give you an understanding of the background. So this is the base MachineHack website. You can see the EI Hackathon page, and you can see all the active hackathon currently on the web page. So currently we have an event on the Great Indian Hiring Hackathon, where you could participate. It's active since 1st November onwards, and multiple corporates are involved for the hiring aspects. You can see the banners here and the job categories which are listed over here. You can work through the solution. It's a classical ML problem. You could read through all the description in this overview and then check out the data over here. If any challenges, you could use the discussion forum. In the submission tab, you can go ahead and submit your solutions. Then upload your notebooks. There's also a starter notebook if you want to get a reference on how to get started with it. So that's also available for you. And there's a live leaderboard of the current rankings and standings in our hackathon. So only 6 days more to go, and obviously the hiring is ongoing at the moment. You can see the timeline over here that starting out from 1st November, the shortlisting was initiated from 18th November onwards. Supposed to end on 26th, so gear up and stay active with your submissions. Obviously, and also if you need any help with the submissions, you could book a slot with us using this link, need help with submissions. That's about one pre-event event we have. Parallelly, for today's agenda, we are going to talk about MLDS hackathon and an ideathon. Let's get started with the hackathon. So this hackathon is more around an LLM fine-tuning skill check. So why MLDS? I will talk about the MLDS conference that's gonna be there in February. It's one of the biggest India's developer summit, and here you can see a lot of speakers and attendees network very well with 3 days event. And yeah, you could check out this website to know more about the MLDS event. And that's the incentive for the hackathon. The top 3 standings in the hackathon and the ideathon each will receive tickets to MLDS. And that is once it concludes on 26th. So let's get started. So for the hackathon, as I just said, the top 3 winners for each hackathon and ideathon will receive the MLDS tickets. Parallelly, also a opportunity to showcase your solution for the ideathon and hackathon at the conference. Going ahead, the theme for our MLDS hackathon. So we have picked a theme for an advocacy of small language models in our hackathon. So the aspect being, as you can see in the chart here, as of now, the mindset has been more data, more compute, and more parameters, the better the model. But then there has been a shift in the thought where we are also advocating for small language models. We want models to be lesser compute intensive, easy to infer, but still perform at par with the context heavy language models. Maybe on a very specific task, but still we want them to be ready to perform at par with the large language models. So the hackathon, as we go ahead, asks you to use LLM models and be able to compress or reduce model size, work on model compression technologies to come up with an optimal model which can perform well on the sequence classification task. The task is very interesting. I will quickly show you the data set. Here we have the training data set for the MLDS hackathon. What you have to do, these are the lyrics to the songs. It could be in any language, not necessarily English, but English derived languages, Portuguese or other Brazil-based languages, European, other segments of languages. All of those songs are, lyrics of those songs are present in the text column. Parallelly, a text cleaned column has been derived on top of it, where we have removed the special symbols for you and a particular classification of that particular song into the relevant genre. We have one hot encoded this label on top of the genre. In the layman terms, we have translated the genre into a particular numerical encoding, and parallelly, label model is nothing but derived on top of label column, which is pending prefix as a label on top of the label column. If you want to clean it other way, you are free to do it. But yeah, that's how the training data looks like. And And as simple as it looks, that's the problem. But challenge comes when you have to perform and improvise the accuracy using the small language models. And so yeah, let's discuss what are some interesting approaches in the market now to go ahead with reducing model size without sacrificing on their performance. So the top three most discussed uh, approaches for model compression are knowledge distillation, pruning, and quantization. Uh, Almost every approach is either combination of one of these, three of these, or the variations of these three. Now, why this problem becomes very interesting? Now, for a sequence classification on the lyrics, we would want models to be able to identify what is a rap song, maybe able to identify the figures of speech used in that particular lyrics, like simile or alliteration or metaphor, maybe the model being able to identify those contexts within the lyrics. That would make it really interesting to see, because lyrics are not limited. They could be of variable length, but for small language models, the context length would be smaller. So what I mean with context length, being able to take maximal length of the text input. It can go up to 500. It can start out from 512 characters, could go up to 64,000 characters for the maximal models, even beyond. But yeah, the task is to be able to train the model using these lyrics data, not limited to that context length, and come up with the right classification as well you can do. So yeah, let's get started. And so first approach to discuss about quantization approach to uh, compress the model size. What is quantization? To quickly give you an overview about it, quantization is nothing but to for numerical data. In case of large language models, the weights and parameters used in the data, we are reducing the precision element of it. So here you can see for different approximations of pi, if we go ahead with floating point 64 precision with up to 10 decimal places of pi, we can approximate it with this binary representation, which is 64 bits long. Then if we just cut down the precision by 50%, we are limited to just 7 decimal places of pi. And then we can represent that with 32, floating point 32 precision. Going down, we have floating point 8, floating point 4. But here we are reducing precision with large benchmarks. The challenge, this similar thing with the large language models, where for different parameters within the model architecture, you are quantizing the weights and parameters in it. Uh, you do it while retaining the accuracy, while retaining the performance of the model. How this helps? It reduces the memory footprint, it improvises the inference speed, those aspects. That's one element of how you could improvise. Also, to discuss some popular researches on quantization approaches, we have two main themes on how quantization shows up in the researches. One is through post-training quantization, another is quantization-aware training. So quantization-aware training is a compute-intensive task, where there is a very interesting paper recently released about era of one-bit LLMs, where they have managed to shrink down the precision to 1 bit and still are able to match up to the performance of Llama model here, while reducing the memory footprint, latency, and inference speed by a large chunk. That's about the quantization aware training part. And for another one, the post-training quantization that we can implement smoothly on our local or edge devices also. So for post-training quantization approaches, we have for the already trained existing model, we just fine tune certain aspects in certain way. Like for example, certain layers within the model we want to quantize, certain weight parameters in the architecture we want to quantize. That we can take up based on our own approach and the task in hand. So we go more on the post-training quantization side. Another one is pruning. Most of you would know pruning. If I take the example of a decision tree, or let's say just a tree, how you do any excessively long branches just to give it a proper shape. we cut it down. So similar to that, we have in a decision tree, we don't want it to go to too much depth to prevent overfitting on those challenges. That's why we take up pruning as a task. While pruning will reduce the depth of a tree, complexity of a tree, we want it to be done in a way that it retains the performance at the same time. That's done with the intent to reduce the model uh, inference speed, improve the inference speed, sorry. And yeah, following that, we have a very interesting approach called knowledge distillation. And that also is explained in two major themes. Using synthetic data and using logits. I will explain you in a bit. So there is a very interesting paper you would have known about alpaca model through Stanford research, where they have used the synthetic data generated on top of the llama model to train the alpaca model, which is a very small model and is able to perform very well on certain tasks on glue data set and glue benchmarks. That's one side of knowledge distillation aspect. Another is using logits. So using logits, the approach is very interesting. We use a teacher-student model. What I mean with that is we use a large model which acts as a teacher to us to say to train a small model which would act as a student. So for example, let's say a 64 billion llama model being used to train a 3 billion model, where what we do, we run same task against both the models and check the outputs in terms of logits. Logits are a form of probabilistic representation of the outputs, and then compare the output of a student model with the teacher model, check the deviation, and then tune or manage the loss, which is the difference between the fuzzy outputs, which is logits, and then fine tune the student model accordingly. So that's about the knowledge distillation aspect using the logits. Now, we have three very interesting approaches where you can have different varieties with which you could implement through your own combinations. But you could combine all three in different levels and aspects to come up with the final more compressed model, uh, which would perform at par with the task in hand. Now, interesting aspect here is to choose the right model. Since we have said that there are multiple languages involved in the training data set, so you would also want to choose a model which has been trained on multiple languages. You would also want to choose a model which performs well on glue task. And glue task or glue benchmark is about natural language understanding. So the models which perform well on glue task, which are facilitated by multi languages support, will do really well on this aspect. Also, just to give you a trick, we can use models specifically trained on poetry level tasks to understand the patterns, figures of speech better. So choice of model, there are many underrated models out there which haven't been touched upon yet. And you could use those to experiment and come up with what works best for this particular use case. So yeah, that's about it. Let's go ahead and discuss how the evaluation will be performed for this hackathon. So the evaluation criteria has been done on hidden 100 test cases. So similar to these lyrics, we have 100 samples of lyrics in different themes and different categories, and model has to give the right output, the right classification for it. So for your models that you come up with after fine tuning, you could always evaluate it in your end before uploading, like model parameter count to understand the memory footprint. Then you have benchmarking using Hugging Face Evaluate library, where you could evaluate your model on top of various runnability parameters. And then you have model profiler through TensorFlow or PyTorch library available for your quick understanding as well. And then you have most important one, the inference rate or tokens per second or throughput of the model. So there we talk about how fast or efficient the model is in terms of inference rate. For example, in our case, where we want for our hackathon, we have set out these constraints. The model footprint being lesser than 6 GB, only that will be accepted as an input. while the inference time being less than 8.5 seconds, which is 8.5 minutes, sorry, which is 510 seconds for our 100 test cases. These are being inferred on this CPU with 2 cores. So you can simulate the similar environment in your local setup and then check how, if the submission would meet these constraints. Um, so that's about the hackathon. I can quickly walk you through how the submission tab would look like so that you have an ease. And any questions you could shoot at me. So you can download the training data set from this tab. Any questions you could always, the discussion forum is open for you. Then submission will be done through this tab. So you have to upload your LLM files, which will be accepted in this safe tensors format, JSON for tokenizer or configuration files, TXT files for your vocabulary files or other supporting files. And solution, you have to put down your worked out notebook, how you have approached the solution, how your training was performed. Basically, you have work out your whole solution either in a zipped format or Jupyter library supported format. So that's about it. And then you have one handy tool to check whether your model will be evaluated right. So in the overview, under the how to approach challenge section, there is a note where we have provided you a script link. Also over here in submission evaluation link, where you can check if your model is runnable on top of this script, then it would be runnable in our internal solution, internal evaluation platform also. So you can run it against the pipeline module in the transformers library and minimal supported library version is 4.30.2. So after, if your model is runnable on this platform and code segment, then it's runnable on our evaluation setup as well. So that's one check you must mandatorily perform before uploading your solution in our submission tab. Okay, so we can see the already existing submissions on the platform over here. And also after submissions, the inference, as we discussed here, can take up to 8 minutes to complete, but that's the maximal limit. If it completes before that, you would be able to see your outputs in or state in the leaderboard. If not, it has either timed out for breaking through the hackathon constraints. So you would have to work out more on to make it more efficient. So that's about it. Further going ahead, we have MLDS Ideathon that I want to walk you through. That's an open ideation competition with inspiration to advocate GenAI applications for the social good themes and support edge device runnability. So imagine a small LLM in your local or phone device and able to perform large variety of tasks. How it would benefit? Let's see. Why edge devices? Because we want it to be real-time performer in our local systems. We want better privacy in today's edge where every single speck of your data, even actions on top of your phone are being used to train models like large action models. You don't want your privacy in any form to be leaked out. So that's the inspiration here, to be able to develop GenAI applications or very miniature models which are able to run on such edge devices and perform at par or with the action expected from them. It's cost effective in terms of preventing heavy inference load and compute intensive environment in the cloud. It's energy efficient, therefore, and then it's also improving accessibility and resilience at the remote areas where network may not be as effective, and still the support is available through the local running GenAI models and applications. We have designed the Ideathon across the 4 major themes on base, and we would like the solutions to be grounded to Indian challenges and aspects. So here you have cybersecurity as a theme where you could touch upon various pathways, like how the cyber frauds take place, what particular kind of uh, pathways in terms of that any person performing actions on his phone, maybe scanning an illegitimate QR code, going to a unsafe site. So those aspects your model should be able to capture and be able to notify the user and recommend the right action effectively in the real time. That's one aspect that we can think of. Various multiple aspects. It can detect spam messages, harmful messages, um, uh, take care of what are the possible threats which you would not have fathomed before. Uh, and that's all running on your edge device without any help from external network. So it prevents uh, any inference or any interaction from outside into your systems affecting anything. So that's about it. That's the inspiration for the cybersecurity theme. Further, we have healthcare. It's a very important one to do a remote monitoring diagnostics or any recommendations using your metabolic data or health right real-time data metrics and provide you right recommendations. That's another. Then another very interesting one, which is about mental health as a theme, where we have uh, where you can think of very interesting solutions like um, you must have read about, or there's a very popular concept now called brain rot. What happens with over information consumption in digital and information consumption, the brain and useless information or information which cause distress or are not really positive in nature. Such information, when fed to our brain for long time, causes this cognitive disablement or memory issues called brain rot. So that's one theme you can think of, how you could prevent end users engaging in such and their lifestyle patterns, their activity patterns on their devices, and be able to give them the right recommendations using these GenAI applications. You could build certain mental health chatbots or recommend them the right diet or such things. Lot of use cases, but all runnable and working through the data and taken from the edge devices. Now that's one thing. Now also governance, where you would want various interesting ones like helping government through your edge devices. For example, you are going around and you see a pothole in the road. If there is a broken wires, you could just take a picture of it, and or your phone would just scan through your photos and be able to identify such problems in the surroundings, be able to tag it and send it over to the right stakeholders to take right actions on top of those uh, problems around you. That's governance aspect. There could be more that you can think of, wide open ideation here, but yeah, the goal is we also want it to be personalized. So let's think about edge device fine tuning. If you can have a model which can actually learn your patterns of how you interact with your phone, your digital devices, your environment, without leaking any of your personal information all on your edge device, and still doing the actions at par with how you would expect it to be. So there you have this ideathon as an inspiration. There are two very interesting papers that, if you want to read it, edge device, edge LLM, enabling efficient LLM adaptation on edge devices, and approaches implemented to enable that. Then you have edge MOE, a more recent paper that how you could on-device infer it faster. So any application which enable this edge device runnability and cater to the social good theme of our competition will be really good to take forward. Now, for the Ideathon, we are accepting submissions across these three levels. You have to share a GitHub repository of your code and all of your implementation, parallel to a documentation which could support re-implementing that particular code. Then a demo video showcasing your solution, less than 15 minutes. Uh, you could host it on YouTube or any other portal public, make it public, and then share video to us. Then you can share with us a deck of which summarizes the whole implementation, highlights the specific aspects of your implementation. If there are any limitations on the previously existing solution that you have improvised upon, that you can take and showcase on through your deck, and the impact that it promises to achieve. Uh, so that's about the submission aspect. Now, the evaluation will be performed case by case basis for each submission, based on the relevance and how well it demonstration has been showcased on your demo or your PPT, and also on the practical aspects on how much it is relevant to the inspiration that we have, or to have it fast runnability on the edge devices and be able to cater to that challenge. So yeah, of course, think of the more innovative and practical applications, and keep the societal impact, the size of impact in mind. That's the tips for win here. I think that's it from my side now. If any questions from your side, I'm open to take it ahead. We'll wait for a few more minutes. If you have any questions about the hackathon or the ideathon, please let me know in the portal here. You could use the chat or in the QA forum here. Let's wait for 3 more minutes. If you want to know more about any aspect of MachineHack, you could always uh, contact us through a Calendly link that we have. Set up a connect with us in the hackathons. Also put out any query to us in the discussion forums, or mail to us on support@machinehack.com. We'll be getting back to you within 24 hours. So that's another way you could reach out to us. There is also a Telegram group which you can join. The links are available in the descriptions of the hackathons. I guess there are no main questions as of now, but yeah, as always, ready to take up your questions through any other channel. Um, Feel free to reach out. And yeah, I think that's it for the day. Happy Friday. And yeah, hope you are going to submit some very creative solution going ahead. There's a weekend coming up. So yeah, brush up and give us some great solutions. All right, then this way, let's close our session. Thank you.